Hey guys, all right, welcome to the last section of chapter 3. This is a really long section, or chapter, isn't it? So the derivative of e to the x. Let me give you the formula first. Okay, the derivative of e to the x, it's e to the x. And believe it or not, we did one of the homework questions already that we proved it. So let me give you the answers and then we'll prove it again manually, or I would say algebraically. So some of you sometimes like to do substitution. So the substitution is if you have e to the u and taking the derivative with respect to x, then it's e to the u times u prime. Okay. So this right here is the formula for the derivative of e to the x. Now, how did they come up with that? Before I prove it algebraically, I'm going to give you the limits. The limits as x approaches 0 of e to the x minus 1 all over x, it always equals to 1. And add this to your list of stuff that you have to memorize. And let me just kind of quickly give you a graph. So when I graph that out, okay, so as you can see, e to the x minus 1 over x, as x approaches 0, the height of this is 1. So based on the graphical, that limit, it's always true. Now let's go back to using that to prove our e to the x derivative. Okay. Step number 1, I'm going to give you y equals e to the x. Okay, so step number 1, I'm going to use the formal definition. The limit as h approaches 0 of f of x plus h minus f of x all over h. Then step number 2, substitute in limits as h approaches 0, e to the x plus h minus e to the x all over h. Then this allows me to write e to the x times e to the h minus e to the x all over h. Now what allows me, how come I'm allowed to do this, right? Well, you're allowed to do that is because when you're multiplying, you can add the exponents if the bases are exactly the same. Well, what do I do with that piece? I will now take out a common factor, which is e to the x. Well, e to the x, that means I'm left with e to the h minus 1 all over h. Well, I just gave you this identity right there. That's why I give you the identity first. So technically, I can rewrite this as e to the x times e to the h minus 1 all over h. This identity, it's 1. Okay? And technically I can put it over 1 right there as if I want to. Well, if that's 1, then I'm just left with e to the x times 1, which is the derivative. So the proof is the derivative of e to the x is itself. Okay? So let's use it on example 1 right away. Example 1, find dy over dx if y equals e to the 2x. You can do the chain rule or you can use u substitution. So let's use u substitution. I use u substitution. You don't have to. U is 2x, so u prime is 2. I will rewrite this as y equals e to the u. So y prime is the derivative of e to the x is e to the x, but in this case it's e to the u times u prime, which I will go further. So that means u is 2x, so that's 2x, and u prime is 2. I'm going to write the 2 in the front. So 2e to the power of 2x is my final answer for the derivative of y equals e to the 2x. Next, I'm going to give you some more rules, okay? The derivative of a to the x power, and let me give you what a is, where a must be greater than 0 and a cannot be 1, because 1 to anything is 1, so that's not very exciting. So what's the rule? The rules are d over dx of a to the x equals a to the x times natural log of a, okay, if that's starting out as x right away. But sometimes we have chain rule, which we use u substitution. Let me highlight all the things that you have to know, okay? The chain rule, sometimes it's a little bit confusing for some of you. So sometimes you're asked to do the derivative of with respect to x, and then you have to substitute u. So how does that look? It's a to the u natural log of a times u prime. So make sure if you're using u substitution, you have to multiply by u derivative. Okay, so here's how we are going to use that rule right away. If I were to go in and say, okay, we'll let u be negative x, that means u prime is negative 1. Then I'm going to rewrite this as y equals 9 to the u power. Well, I just wrote down my rule, so y prime is, the rule says a to the x, well, let's use u, a to the u times natural log of a times u prime. I already have everything. A is 9, okay, so I'm going to write 9. U is negative x times the natural log of 9 times u prime, which is negative 1. Then I'm just going to put that negative 1 in the front. So final answer is negative 9 to the negative x times natural log of 9. And box that up. Okay, so our next rule is the natural log of x derivative. So the rule says, with respect to x, natural log of x is, I love this one, is 1 over x. Now, would it be okay if you have u substitution? Of course. So if you have u substitution, then it's 1 over u times u prime. So either one will be fine. And again, make sure you start making a list or flashcards of all of this stuff. Excuse me. Let's do example 3 using that same exact rule that we just got done writing. I'm going to use y prime is, okay, I'm going to use the chain rule. This one looks like I have the power rule. So I'm going to take down the power, which is 2 times natural log of x times the inner component derivative. Well, 2 times natural log of x, the derivative of natural log of x we just got done writing, it's 1 over x. So let's move that to the front. So that's 2 over x times natural log of x, and box that up. We have another rule, which is log base a. Okay, I'm just going to pause for a little bit so you can start writing the question. Writing the work for example 3. All right, so last rule. Ready? The last rule is derivative of log base a. Let me give you the restriction for a. A must be greater than 0, and a can never ever be 1. Okay, so the derivative is d over dx of log base a of x is 1 over x times natural log of a. Box that up, highlight that, because that's what you need to know. Now, how come if some of us like to have u substitution, it's okay too. It's 1 over u times natural log of a, always the chain rule says times u prime. So if you use u substitution, don't forget to multiply by the derivative of u. And this is the end of this this video notes.